Hello everybody. Today we're going to be taking a look at this problem, reversing a linked list. So given the head of a singly linked list, reverse the list and return the new head. So this is a pretty straightforward problem. Basically we have a linked list, a singly linked list, meaning every linked list, we have the class defined here. It consists of a value and a pointer towards the next node. As you guys probably know already, a linked list is a series of connected nodes, and yeah, each node has a value and a pointer towards the next node. And essentially what we want to do is, in a singly linked list, it will be something like this, where each node would be like continuously pointing to each other, and all we want to do is each of these arrows, instead of going like this, we want to move each pointer backwards, basically like that. Normally I would do this kind of thing on the drawing whiteboard, but I don't have that available right now, so we're just gonna have to go through this. And essentially that's essentially what we want to do. So how would we go about doing something like this? Well, what we want to do is we want to have each node, we want to traverse to the next node somehow and then change the pointer to the previous node. However, if you might notice, when you're trying to traverse to the next node, it's not easy to figure out. There's no pointer going back to the previous node. So what we need to do is, instead, we need to save the next node in the variable, and then we can reverse the pointer of the next node, and then we can move forward and then continuously go onwards like that. So let's see what I mean by making the list function here. So we're going to start reverse linked list. All we need to do is take a head as the input. And yeah, basically what we're going to have is we're going to have two variables. One is going to be a temporary variable called previous. And this is where, instead of notice that each node has a pointer to the next node called next, we are going to set each node to have a previous pointer. So a node to the next pointer is actually going to be previous. Right now, the previous of the head is none, because obviously starting from the head, there's no previous node, so it's set to none. And we're going to have a node called current, and we are going to start it at head. So it's going to start at the head and continuously traverse through. So let me just quickly do this where I where's the minus greater than? Yeah, so it starts out like this, right? Now what we want to do is first traversing through the linked list. An easy way to do that iteratively is by saying while cur. Basically, while cur means that while current is not none, if cur is ever none, that means we've hit the end of the list and we can't go anywhere. So that's why we're using while cur to traverse through the list. What we want to do is we don't want to immediately go to the next node. What we want to do is save it in a temporary variable. So we're going to save the temporary variable in something like next. Next, NXT is a summarized version of like next. I don't want to use the same one just for confusion's sake. So NXT is equal to current.next. So now we saved basically the pointer to the next node. And now what we want to do now is cur.next. So we're setting the head to the right now to the previous node. Right now the previous node is going to be none. So we're essentially setting this thing to the previous node like this. Obviously this one doesn't have a pointer, so it's just going to be none. So this wouldn't be anything. Current next is equal to proof. I didn't finish typing that out. but that's what we're doing. We're setting this thing, the current pointer we're on, we're setting it to the previous node that we have. In this case, it's none. Now, what we want to do is that previous thing, we're going to move it up. So we're going to move it to the current. So previously it was none, but now it's moving to the current where we're at, cur. And now finally we can go to the next node. So the code may look very simple, but the key thing to keep in mind is we have this previous node that's traversing through. It's starting at none, and then it's continuously going to each node. We're setting the current.next to the previous node, but we need to make sure to set the next beforehand, because if we don't do that, we won't be able to traverse at the end here. So current is equal to next. This is what's allowing us to traverse through while we're doing setting the current.next to the previous pointer. So hopefully that logic was pretty clear. And at the end of this, all we need to do is return proof. So now we can test this code. Let me just comment that out. So let's get a linked list node. I'm gonna say, let's say head is equal to this. Sorry, I forgot I put this entire thing inside the thing. There's no reason for it to be in the class node, the node class. Basically, we got this head. It's going to have the list node as it has the first value of 1, and then it points to 2, and then it goes to 3 basically. So the linked list would look like 1, 2, 3 basically, and what we want is we want it to go to 3, 2, 1 instead of going from 1, 2, 3. We want it to be 3, 2, 1. So hopefully if we did everything right, we can set the new head, because what we're returning here is the new head, is the reverse linked list. And now what all we need to do is we can print out the linked list. To print out a linked list, it's pretty simple. Just like we did here, we're going to use a while cur. We're going to set current to actually I think it's better if we do two tests. So we'll do one test beforehand, before we do the thing. So current is equal to new head, cur is equal to head, while cur, wait, shoot. We're going to print cur.val, and then we're going to say end is equal to this. And basically in Python, when you put end is equal to this, a print statement, it could typically only have one argument, but if you put this end argument here, it will end with this thing, plus it will make sure to always add the last this thing towards the end of the string that we wanted to print. So yeah, we can test that, and let's just copy paste this whole thing for here. Now we're gonna say here, so what we're gonna see is that this first one should print 1, 2, 3, similar to this, and then when we flip it around, it should be 3, 2, 1. So if I did everything right, let's run the code. Hold on, there might have been an error. Oh, obviously I forgot to say cur is equal to cur.next. That's my bad. That's how you increment through the loop. So now that we got that, let's take a look, and let me just split it up just to make it look neater, but you already see that we got from 1, 2, 3, and then 3, 2, 1. So let's print, I'll just do a \n here. And yeah, here we go. So we first get the 1, 2, 3 in this first thing, and then we reverse the linked list here. It did the space, and then we get here. The reverse linked list is 3, 2, 1. And this can go as long as we want. You could test it with other examples on your own. But yeah, this is essentially how this code works. Hopefully the logic was clear, and yeah, that's pretty much it. I'll see you guys in the next time. See ya.